Hello, welcome to today's lesson. Today we are looking at logarithms. Right, so we looking at the logarithms. Now, what is a logarithm? A logarithm is actually an exponent. If we have the function y equals to a exponent x, this x here, it's actually our logarithm, which is written as log. Right, so in other words, if we have maybe we have an exponential equation 2 exponent x equals to 8. Right, so this x, it's a log or a logarithm. Now, how do we get this logarithm? We say this x is a log. Now, if you look at this, this is the base, our 2 is the base, and this 8 is a number. Right, so the logarithm, the exponent is a logarithm. So we say x is a log, and the number is 8, and the base is 2. So this help us to calculate equations. Remember, if I have 2 to the power x equals to 8 and I'm solving for x, I can simply say that 2 exponent x equals to 8, which can be written as 2 to the power of 3, and we say x is 3. But then imagine if I have 2 exponent x equals to 15. Now it's very challenging to be able to write 2 exponent x as 2 exponent something there, so that we can say x is that number there. Right, now how do we get the answer there? We can simply say, okay, because we know that this is a log, it's a log, so we will say, all right, the x value is a log. Now the number is 15 and the base is 2, so we can be able to get that from our calculators and get the answer there. So what I'm trying to say is that this log thing has made it easier for us to be able to solve such equations. Now that is why I'm saying the exponent is a log. So we are going to look at a few things pertaining to logarithms. For example, if we have let's say 2 exponent x equals to 10, and we want to change this to log form, it's in exponential form, we want to change it to log form. So if we want to change this to log form, we simply say, because the x is a log, so we, as I said, we just say x equals to, and we have log, the base is a 2. Remember, you need to know which one is a base, which one is the number. So the base is a 2, the number is 10. So we will start with the 10 and say this is 10 base 2. So that's how we even call it. So we say this is x equals to log 10 base 2. So we must get used to saying it that way. We say this is log 10 base 2, and so this is how we move from log from exponential, this is exponential form, to log form. And we can even do it vice versa. We can move from log form, for example, if we have y equals to a log of, let me just say, b base a. So we can change this is log form, we can move it to exponential form. So the exponential form, remember, this is the base. If you can know the base, this is the number, and this is our exponent. We said a log is actually an exponent. So let's see, we have the base is a, the exponent is y equals to the number which is b. Right, so we can move from log form to exponential form. So in other words, if we want to solve a log equation, let's say we have x base 2 equals to 32, or whatever the number that may be. So we want the value of x. Let's make this smaller. So let's make it smaller. Let's just say it's 3. Let's just say it's 3, not 32. So now we want to solve for x. So remember, the best way is to change this from log form to exponential form. So this is the base. Let's mention it. This is the number, and this is the exponent. Oh, so that when we change it, we will say the base is 2, the exponent is 3, equals to the number which is x. So it means x equals to 2 to the power 3, which is 8. So it means x is 8. So you see, we can be able to solve for x. So we need to know how to change from exponential form to log form, and from log form to exponential form. And we should know when do we exchange to exponential form, when do we exchange to log form, and what the advantages therein. So you see, here in this case, it's advantageous for us to change it to exponential form, because now it gives us this equation which is easy to solve. Now we can just say 2 to the power 3 is 8. So we were able to get the value of x. Right, there are some few rules or laws of exponents that I just want us to look at. So we won't really go into details about these laws, but I just want you to know them. Number one, the log of b base a plus the log of c base a. You see, as long as they have the bases are the same, then this can be the same as the log of, you see, we multiply the b and the c, so it will be bc, and the base it's a. For example, if we have log of let's say 3 base 2 plus log of 4 base 2, this will be the log of 3 times 4, which is 12 base 2. Right, so this is just some laws I want us to look at. Okay, number 2, if it's minus, same thing, log of b base a minus log of c base a. This is the same as the log of bc. I mean, as we divide this time, so we'll have a b divided by c, and then the base a. For example, if we have log of let's say 6, log of 6, it must be a number there, log of 6, let's say base 2, minus log of 3 base 2. So this will be the same as log of, so we'll say 6 divided by 3 and then base 2, so which will actually be, if simplified, log of 2 base 2. Right, that is for subtraction. Right, the other thing that I want us to look at is that log of b base a can be written as log of b divided by log of a. Therefore, if this brings us to this law that if we have log of a base a, this will actually be the same as log of a divided by log of a, which is actually 1. Right, so therefore log 2 base 2 here in this case is the same as 1. So we need to look at this one. So number 4, if we have a log of, let's say, x to the power 3 base a, now we will say this is, we take this 3 in front there, so we'll have a 3 and then log of x base a. So this is what we can be able to do. Right, now a log without a base, we assume that the base is 10. For example, if we just write log 5, it means this is actually the same as log of 5 base 10. So if the base is not there, then we know it's a 10. So we need to remember that. So now therefore this brings us to this. If it's log 1, it's actually 0, and then log 10 will be 1, because remember the base is 10, so it's log 10 base 10, which is 1. And if we keep on adding zeros, we will keep on having such. For example, log, let's say right, so this is 10,000, so it's 10 to the power 4, because the base is 10, so it means, remember the law, this will be a log of 10 to the power 4 base 10. So if we bring the 4 that side, so this is going to be 4 a log of 10 base 10, which gives us 4. So these are some of the laws that we need to understand. So log of 0 is actually not defined, or a log of a negative number. So the log of a negative number, it also is undefined and undefined. So a log of a negative number is undefined. We cannot define a log of a negative number, so it's actually undefined. So we can't define a log of a negative number. Right, so meaning for example, log of a negative 5, it's actually undefined. So all logs are positive. So, but I don't mean that a log cannot give us a negative answer. I don't mean that. For example, it's a log of half. You see, this will actually give us a negative answer, right? So do not confuse what I said here. I said a log of a negative number cannot be defined, but a log of half, it gives us a negative answer. So we need to understand that, right? So now we have learned a few things about logs. We know how to change from exponential form to log form. We have looked at a few rules about logs. So let's get into a logarithmic function. So let's go to a log function. So it's y equals to log x base a. Let's look at this one. Right, we are looking at the shape of this graph, the log function. Remember the y-axis, it's actually the asymptote. Now if it's an increasing function, like this, then it means that the value of a, it's more than 1. a is more than 1, but it can be a decreasing function. If it's a decreasing function like this one, so it means that the value of a is between 0 and 1. So it's never 0, it's never 1. So it's between 0 and 1, then the function will decrease. But like we said with the exponential function, there's no need for us to cram that. We can get the second point so that we can be able to get the equation if we calculate the equation. So now let's look at how to sketch the graph. So let's say we want to sketch the graph of y equals to log x base 2. So we are going to sketch a simple graph of log x base 2. So we can see that the asymptote is on the x equals to 0 on the y axis. So we look at the intercept. So let's start with the intercept. So y-intercept, we know that x value is 0. So we will have the y-intercept as y equals to log, we put a 0 there, and we have a 2. And like I said, we don't have a log of 0. So the y-intercept is undefined, so meaning there is no y-intercept. So meaning our graph cannot cut the y-axis. Right, now let's go to the x-intercept. X-intercept, so we know that the y value is 0, so we will put a 0 on y. So we will have log x base 2 equals to 0. We want to solve for x, so the best way here is to change from log form to exponential form. So we start with the base is 2, the exponent is 0, so the number is x, so it means x is 2 to the power 0, which actually gives us 1. So it means our graph will cut the y-axis, the x-axis rather, at 1. So x is 1. So now, like we did with the exponential function, we want the second point so that this graph can give us direction. So remember, it's 1 here. It can either be this way or it can be this way. Even though we have already explained that as long as the value 2 is more than 1, we know that it's going to give us this function, but we don't have to cram that. The best thing to do is to get another point. So let's say, remember our graph is y equals to log x base 2. Now we know it cuts at 1. So let's say the other point is where x is 2. So let's take it where x is 2. It means y will be 2 to the, excuse me, we will have log 2 base 2. Now log 2 base 2 is 1. So it means the other point is where x is 2. So it will be where x is 2 and the y value is 1. So now we can sketch our graph. So we set the graph cuts at 1, axis at 1, and then the next point is where x is 2 and then the y value is 1. So let's see where this point is. So this is our point, so this is our point, and then it cuts here and it passes there, so we can join this and then we have our function like that. Right, remember this is the asymptote, so it will just come closer and closer. Right, so this is how we sketch the graph of a log function. Now now we know how to sketch the graph. Can we go to the equation? Let's say this is the graph, we see it been sketched and we want to calculate the equation. So the equation of this graph, will say it's y equals to a log, we can see it's a log graph, it's log x base a. Right, now if we look at this, we have a point where x is 2 and y is 1. So we're going to substitute that point there on x and y so that we can be able to calculate a. So now y value is 1 and x value is 2, and then we have base a. Right, so now we are going to change from log form to exponential form like we have learned. This is the base, this is the number, and this is the exponent. So we are going to say base a to the power or exponent 1 equals to the number which is 2. So it means a is 2. So if a is 2, it means our function will be y equals to a log x base 2. So you see, we are able to calculate the equation. Right, simply now let's go to the domain and the range. We look at the domain and the range. Now the domain, let's start with the range this time. Now with the range, if you look at our function, it can either be this or the other one. So any value, it's defined. If any y value, it's defined. So we'll say y takes all the values. So y is an element of real numbers for the range. So the range of any logarithmic function, whatever value of y will give us an answer. Right, so but with the domain, let's look at the domain. So like I said, with the exponential function, with the log function, they are unlikely to ask about the range because it really is not giving anything. I mean, the answer is just y, it's an element of real numbers. So but they will ask us about the domain this time. Now what is the domain of a logarithm? So we will say the domain, it's x, it's anything more than the let's say the q. So this q, it's that asymptote. So in this, the graph that we have been drawing, remember, let me remind you. So this was our graph. So it's the asymptote is at 0. So it means here we'll have x, it's greater than 0 as a domain. So that's how we calculate the domain and the range. So they will more likely to ask us about the domain than anything else here. So we can do our transformation also on logarithm. We can shift the graph. For example, if we have the graph of y equals to log x base 2, so let's say we want to shift the graph. Let's say we want to shift the graph 1 unit up and 2 units to the right, to the right. So let's see what the equation will look like when we shift this graph 1 unit up and 2 units to the right. So we'll have y equals to log, so we have the x base 2. Now up and down, we will just 1 unit up, so we'll just add to the whole thing there 1. Left and right, we do it on the x-axis, so we will do it here. So let's just put it inside the bracket to show that it's one thing. So to the left we add, to the right we subtract. So they said we must go to the right, so we will subtract 2. So this will be the new function. It will be the new function, this one. So that's how we do translation. Right, so let's do reflection. So let's do reflection. Reflection. Okay, now If we do reflection, so let's look at our 3 reflections along the y-axis. Let's take the graph y equals to log x base 2 and we reflect along the y-axis. Remember, reflection along the y-axis, x changes the sign, so the answer will be y equals to log, now the x, it will be negative, so that will be the graph when we are the new equation reflected along the y-axis. So let's look at the reflection along the x-axis. Reflection along the axis, so the x-axis, y changes the sign, so we will have minus y equals to log of x base 2, so multiplying by minus both sides, so we'll have negative log x base 2. So that will be the reflection along the x-axis. So that is how we do a reflection along the x-axis. And the last one will be the reflection along the line y equals to x. Now remember, a reflection along the line y equals to x is the same as calculating the inverse. So we will say we want to reflect y equals to log x base 2 along the line y equals to x. Right, step 1, we exchange x and y. So where we see y, we'll put x, and where we will see x, we'll put y, and then this is what we will have, and we solve for y. Now we want to make y the subject of the formula, so we are going to change this from log form to exponential form. Remember, if I have to repeat this, this is the base, this is the number. It becomes easy when you actually name these things. This is the exponent. So so if we start with, we can start with the number y equals to the base is 2 and the exponent is x. So this is the inverse of that function. So this is the reflection, and this is how we calculate the inverse or reflect along the line y equals to x. Thank you very much. Please do not forget to like, share, and subscribe. Thank you.